Hello, hi, I'm Hoche. Welcome to my channel. Welcome to my home. Uh, as you may know, I enjoy repairing and restoring audio equipment, vintage electronics in general, as a hobby. Um, and I have here a BRYSTON 4B, belongs to a friend of mine. Um, uh, and It's got four blown but the one channel works. One channel has blown output transistors and a barbecued preamp board. One of the preamp boards is just pretty bad shape. Um, One cool thing about these amps, they're modular. You can take them apart rather easily and separate the pieces. So, for example, if you have one bad channel, you can actually swap. You can actually swap one channel for another. Put it. You can just put it on the other side, and figure it out if it helps you troubleshoot. So in this case, the bad board is so cooked that I'm actually gonna use the good board to look at the components that I will need to rebuild the bad board. Here's the uh, output board. The video doesn't do justice to how bad this looks in person. I mean, it looks really bad in person. Let's see if I can focus in a little bit. See over here, this whatever was here is completely gone. Look at this. We have a barbecued board. Look at this. Look at this. You can see the inside. You can see the inside of this guy. Look at that. So, and there's always, oh wow, look at that. Got the cables exposed. Wow, that's terrible. Absolutely terrible. So, I mentioned before, I've never seen a board like this. Usually, the output transistors are blown and they create a short, and it pops the fuse, and that's it. I never actually seen a board this damaged, but I think I have the forensics here. This is the test points where you measure the bias across these two pins with your multimeter, and you use this potentiometer right here, and you set them to, I think it's like a 6 millivolts or 12 millivolts, whatever the service manual says. I'll adjust it to. But taking a closer look over here, see how these melted, the tips melted, and I see a resistor here that's not original. So somebody worked on this amp. So I believed an incompetent technician, or a technician with a shaky hand or something, caused a short circuit, or maybe, wow, I don't know. All right, well, I'm going to replace all these parts and the output transistors are shorted. So I'm going to replace the output transistors and all these parts and these electrolytic caps and this and this one and that one, and see what happens. Because some parts also, you know, I gotta test all these transistors in this board, because you know, there's some parts are obviously damaged, but there's also parts that get damaged and the damage is not visible. So basically I have to test, you know, check every transistor in this board. Even this pot could be cooked. But you know, also it's perfectly fine, but I'm gonna change it also to make them all the same, and use the same resistance that are in there originally. And this is a good board. It is a blessing. It's a blessing to have, because as you can see, I can't even see what was there. So I'll come to this board and identify the part on this board, on the good board. It's always a blessing to have a working channel. If you have a stereo amplifier and one channel works, it's always a blessing, because the good channel helps me troubleshoot the bad channel. And let me see. Look at that also. There's some damage over here, and also where it connects to that board. That board connects right here, and look at that. So there could be, you know, there could be a bad component on this board as well, but that's very easy to test. I can actually grab the working channel and put it on this side, because the output, see, this, it's modular, so these two channels are identical. Left and right are identical and interchangeable. A list of parts, and I went to DigiKey and Mouser. So some parts were, you know, cheaper on one website than the other, or some parts Mouser don't have but DigiKey has, and some parts DigiKey has and Mouser doesn't. So let me show you. For example, I have my shopping cart, and I have a list of parts, and I always get a few more. So it's some of these caps, it's a lot cheaper if you get 50, or if you get 10 instead of 1. So like if you buy only one, it may be like 50 cents, but if you get 10, they're like 40 cents each. But if you get 50, they're like 30 cents each. So that really, that helps. You know, the most common values like 10 microfarads, 47 microfarads, 22, 220, 100, stuff like that. And if it fits, I get higher voltages. So in the future, if I need a capacitor, let's say I need, for example, a 22 microfarad cap, 100 volts. So, you know, I may have it. Maybe I need 63 volt. But if I can buy one that's 100 volt and it fits, I'll get a few of those, and then in the future, you know, I'll have the cap that I need without having to order. So I'm gonna place the order, and when the parts come, I'll install it and keep you posted. I'll be right back. Here are the 8 output transistors removed, and I'm going to do a quick test to see which ones are completely short-circuited. If there's any that is not completely short-circuited, I'm still not going to use it in this amp. All 8 output transistors are going to be replaced. Okay, that's completely shorted, as you can see. You see, if there's a short circuit, it beeps. Okay, let's see. Oh, this one is not shorted. I'll put this one to the right. And this one is not shorted. Oh, I'm surprised. Okay, this one's shorted. Not shorted. Oh yeah. Between collector and emitter. This one has a double short. And this one is also shorted. And this one is not shorted. Okay, so 5 were shorted, 3 were not, and so to test to see if they're good. So this is what I'm gonna do. If it's an NPN, you put the positive on the base, and then you test between base and collector and base to emitter in diode mode, and you get a voltage drop like 0.5 to 0.7. So let me test this one. I'm gonna put it in diode mode. Let's see. Okay, so this one is okay. So this one, it's a PNP, and it's okay. Okay, that one's okay. So I'll save that for the future. Okay, this one is. What's going on? Oh, it's just okay. This one's open, actually. I never see open transistors. This is rare. I'm not used to see them open like that. You always, huh? Well, you know, I just do this as a hobby. I am not a professional by any means. And this is actually the first time that I see one that is just open. Huh, not shorted, but open. Okay, so it's a different type of failure. Okay, so that's why it didn't test as a shorted, because it was a different type of failure. It was actually open. And this one's, oh sorry, I was blocking the meter. This one's okay. Here are the driver transistors. So here are the driver transistors that drive the output transistors. So the driver transistors send a preamplified signal to the output transistors to be amplified. And there's 4 of them. There's 4 of them, 2 PNPs and 2 NPNs. The original ones are SJE 1491 and SJE 1490. Two of each per channel, two PNPs and two NPNs, and you can substitute them with MJE, the modern equivalents, and this is what BRYSTON recommends, and this is what BRYSTON uses. MJE 15030 and 15031. You know, there's NPN and PNT and PMP, and you can also use MJE 15032 and MJE 15033. And the reason why you have two different numbers is, again, because some are NPN and some are PNP. So you get two different types. So I'm gonna take them out and test them exactly the same way in which I tested the output transistors. You know, using the diode. Well, first I'll check for shorts. And if there's one that is not shorted, these little ones, quite frankly, I'll throw them out. I'm not gonna use them again. I believe there's one shorted, but I would change. I would, of course, replace all four. Why? Because these are $1.50 each or so, and it's just not worth it. The modern ones are much better. So, but I would put it in a continuity mode and check. Something peculiar and interesting about these amplifiers is that the drivers and output transistors are not soldered in. They have sockets, pins and sockets, kind of like the vintage vacuum tubes. So to remove them and install them, there is no soldering involved. So I'm going to remove the board. The parts are ordered. I'm going to remove the board and start changing what I can, cleaning the board a little bit. I'm going to remove the burned part of the circuit board. I'm going to scrape it, kind of like when you burn your toast. I'm going to scrape that off because that can be conductive. So not very conductive, but it can be conductive. So I'm gonna scratch it off, clean the whole board with a Q-tip and alcohol, and so that the board is ready when the parts arrive. I believe a couple of days, I'll be ready to just start installing the parts. To clean the heatsink thermal paste, you can use alcohol and paper towels. So what I do is just spray some alcohol on a paper towel and just wipe it off, just like that. Okay, so that the heatsink is ready for new thermal paste and reinstalling the transistors. These are the old mica insulators. So these go between the heatsink and the transistor to isolate the transistors electrically, and still let the heatsink and still let the heat pass. You know, there's still some thermal resistance, but you gotta have them. You gotta have the transistors electrically isolated from the heatsink. I am removing the burnt parts from the circuit board, and in these cases it's easier to cut the part out and then remove the pins, because now we have less mass. There's less mass, so you can heat up the old solder easier. So that's what I've been doing. Just cut out the part that I'm removing, and now I can grab tweezers and the soldering gun. A soldering iron, I meant. And heat it up. Pull the pin. Okay, then take the desoldering tool, and clean out. And you know, that works easier for me than desolder the whole part. So just cut the part out, and then just remove the pins and then the solder, in that order for me. And Q-tips and alcohol. With Q-tips and alcohol, I'm cleaning the board. And also another thing that I'm doing is I'm scraping off the carbon, the burnt parts of the circuit board, because it can be conductive. So just like a burnt toast. All right, so that's what I'm doing for now. And the parts, as already mentioned, the parts are on the mail, arriving the day after tomorrow, so that I'll have the circuit board ready, install whatever seems burned, and then test to see, because again, there may be parts that went bad and don't show any signs of damage at all. So I have removed four of these transistors. This was the one that you can see the inside. You can see the inside of it. Base collector emitter right there. Base collector emitter. All right, some burnt resistors, some transistors, some capacitors. It's probably superficial, but it's still, of course, replace it. It's a 40-cent part. On this part of the circuit board, a trace, one of the traces like this, was completely burned out and destroyed. So I use a piece of copper desoldering wick. Sometimes, if I need more power transfer, I use a copper, just a piece of copper wire. In this case, it is very small and thin, and conducts very little power, maybe a half a watt, eighth of a watt. So for this particular application, this being flat worked better. I scraped the cover and exposed a bare copper, and then put the wick on top and solder it all along. So it's a bridge. It doesn't look very good, but it is very well connected. It's a electrically it is just fantastic. Visually, well, you know, it a bit ugly, but functional. Another problem with the traces, over here there's no trace, and on the bottom there's also no trace. By looking at the good board, it's almost invisible, but under this resistor I could see that there's a little bit of trace that goes from this point to this point and connects here. So the easiest thing for me to do at this point is I'm going to take the leg of this resistor that I'm soldering in right here. I'm gonna bend it over and bring it to where it connects. Okay, problem solved. Now, this Frankenstein looking board is not pretty, but hopefully functional. And I made sure that it makes a good connection, metal to metal, not just soldered, but it's actually making contact. That's why I pushed it in with a dental tool. These dental tools are fantastic. They're a must. And this spatula has a million uses. It's a dental spatula, and my God, you can use this for an infinite number of things beyond just electronic repairs. Okay, so if you look over here, you see how the trace was compromised. It's still making, it still has some left, but it's been compromised. So I added a nice piece of copper wire, and I'm gonna solder it right there in place. And that should be the final circuit board repair. This is the Frankenstein project. All right, hopefully that's it. I finished the work on this amplifier board. I went ahead and took all the measurements that I could. The way this amplifier is designed, unfortunately, I cannot test it, plug it in and test it, because I would need a harness. Once I install the amplifier, there is no room for me to troubleshoot, trace a signal. So if it doesn't work, it's gonna be a nightmare. I have to basically troubleshoot the unit without power. Usually I put power on the unit and apply a signal and trace the signal. But again, the way these amplifiers are designed, once I install this module, there's not a lot of room for me to be probing and tracing a signal. So I measure all the resistance. I tested all the transistors with a multimeter in diode mode. While checking the resistance, I realized some resistors that were labeled as 20 were really 200. So I don't know if you remember before in the video, I had a 20 and a 2 ohm resistor to make a 22. Well, it ended up being 202, not 22. So I had to remove those, and then I was able to find 22 ohm resistors. So I installed those. So I am now going to apply some thermal grease and install the drivers and output transistors, and plug in the module and see if I get sound. This is the moment of truth. The repaired amplifier board has been installed in the amplifier with new output transistors and driver boards, and of course new thermal grease. The drivers that I use are MJ15030G and MJE15031G. The output transistors are MJ15022G and MJ15023G. And of course, I checked, double checked, triple checked, and quadruple checked to make sure that I got the PNPs and the NPNs in the right locations. Otherwise, we would have magic smoke. We would let out the magic smoke and it would suck. If you put the NPNs and the PNPs in the wrong location, that would not be good. That would not be good at all. So like I said, I quadruple checked that, and with a multimeter, I went over the board over and over and over again to make sure everything was okay, because once I have this installed, as you can see, there is no room for troubleshooting. So if there's a problem, I have to take it out again, probably build a harness. It would be terrible. It would suck. I have a dim bulb connected to the in series with the amplifier to limit the current, and I have a 1 kilohertz test tone connected into the amplifier, and I am ready for testing. I am nervous. I hope it works. Fingers crossed and prayers. Oof. If it doesn't work, it's gonna suck, but I will fix it. I just hope it's ready. I hope I get a tone. If so, I would proceed to adjusting the bias. I would show you how I adjust the bias in accordance with the service manual. And all right, guys, here we go. Oof, oof, oof. Please work, please work, please work. Yes! Yes! Woohoo! Oh my God, those were some tense moments right there. All right, that is absolutely fantastic. I have a clean tone. I'll go ahead and adjust the bias and everything. Take a look at the output wave on the oscilloscope. But it's ready. It sounds that's a clean wave. Absolutely fantastic. If you like this video, please like and subscribe. I would really appreciate it. I would really, let me turn this off. I would really, really, really appreciate it if you like and subscribe. And Rocco would also be thankful. Thank you so much. Forgot to mention the reason why it would have been so terrible if the amplifier didn't work and I had to take it apart again was not the fact that I would have to remove this module. That is extremely easy. But to work on the PCB, you have to remove 9 transistors, clean the thermal compound, reapply the thermal compound, and reinstall the transistors. And believe it or not, the process of removing, cleaning, and reapplying thermal compound takes me about 2 hours, hour and a half, 1 to 2 hours. It's messy, it takes time, it involves a lot of alcohol and tissue, and that's the part that I didn't want to go over again. And like I said, once you install this, there's no room for troubleshooting like on a regular amplifier that you can open it, have access to the PCBs, put a signal, turn it on, and trace a signal. Not happening. The good thing is that these boards are, this is different by the way, but the boards are relatively simple, so you can go through them. You can go through them with a multimeter, but you can still miss something. And if you do miss something, well, you got to go through all that thermal paste cleaning and reapplying again. And that's why I was so happy when it worked. Okay, guys, I'm adjusting the bias. I couldn't find a service manual for this unit specifying the bias, but I called BRYSTON tech support, and I was told to set the bias so that the sum of both test points, there's a test point in the bottom and a test point in the top, so that they add up to 12 millivolts. So the adjustment, it's this knob right here. Counterclockwise makes it go down, clockwise makes it go up. I'm gonna move it a little bit just so you can see it. See, that went down. So I'm gonna bring it up to about 6. All right, and that's how you do it. Gotta be very careful. I see some marks over here. They look like burn marks, and I suspect a previous tech, probably shorted out, the test points to this bar over here. So one must be very careful. I put some a tape on the screwdriver to minimize the chance of causing a short circuit. Okay, so I'm gonna set the check the other points, but basically it's the same process, and set the bias for the other channel as well. And then gonna hook it up to the oscilloscope and take a look at the waveform. Forgot to mention the DC offset. If you have DC voltage at the speaker's output, you bring it down to 0 at this adjustment over here, the blue adjustment over here, counterclockwise brings it down into the negative, and clockwise brings it up, makes it more positive. You want to bring it to 0, so it can be negative something or positive something, so you want to bring it down in magnitude. Right now it is just, that's absolutely beautiful. You can have on the older ones that didn't have this adjustment up to 50 millivolts. So this is, I mean, oscillating around 0. But I'm gonna bring it down just a little bit. There's not much to adjust over here. But there we go. Okay, now it's kind of oscillating around the 0. That is just perfect. That is very, very, very low. That's nothing. That's really nothing. That's no power at all. You square that and divide it by the impedance, and that's the power. So, you know, and that's millivolts. That's not even volts. That's millivolts. So that is just incredibly negligible DC offset. So we are in business. That's fantastic. And as you can see, we have absolutely perfect, beautiful sine waves on the oscilloscope. Both channels perfectly matching. So we're in business. All's good. What do you think, Rocco? They look good? What do you think? Woohoo! Say hello. We have sine waves. Looking beautiful. Absolutely beautiful. And finally, guys, the most important test in the world, the listen test. I've been listening to this amplifier and I love it. Usually they go for about half the price of an equivalent Macintosh power-wise. You know, compared to a Macintosh of the same power, I would say they usually go for about half. And they're absolutely fantastic for any audiophile that don't want to spend as much money as in some other brands. You know, you can have absolutely wonderful sound for a very fair price. And I love the bass. This amplifier really has a grip on the woofer. It is very smooth, silky, great sound stage. You know, really good amplifier. Absolutely wonderful quality. I have it hooked up to my Macintosh tube preamplifier, a C2200, all analog, and it's connected to a pair of Klipsch horns, and I'm gonna be enjoying it until my friend Manny comes to pick it up. I just fixed this amplifier for my friend Manny. I've been repairing amplifiers as a hobby for a few years. I got into it because in Miami, I live in Miami, and there's a lot of incompetence. People that just don't care. Like, you call a plumber, you get a clown. You call a carpenter, you get a clown. You call an electrician, you get a effing clowned. Unscrupulous people just want to rip you off. And I had a few techs do horrible work on my unit, so I would get home and take the crap out that they installed and order good parts. I didn't know how to fix them back then, but I could solder. So I would remove what they did and do it again. And, you know, just after getting fed up with incompetent technicians, I just decided to say, what the heck, and started troubleshooting the units, looking at the schematic diagrams. I had to pretty much teach myself about semiconductors and electronics. But once I started doing my own work, due to lack of competent technicians in Miami, I kind of fell in love with it. It is extremely distracting and peaceful, and it's like an art form for me, and I really enjoy it. So I hope you enjoy watching this video. If you did, please smash the like button, like and subscribe. I would really appreciate it. Hit the like button, hit it hard. Thank you very much.